I guess good morning. We'll wait for a couple of minutes for others to come. Hi guys, good morning. Let's get started. So we have been discussing the topics on networking. So we continue to do it. We have a few more topics within that, which include load balancing and site-to-site configuration and point-to-site configuration, and then a couple of other small topics. Uh, and we will be completing the networking concepts, sometime by the mid of this week or at least by the end of this week. Okay, so that's what the plan is. So what did we discuss in our last class was on load balancing, right? Which we did discuss some theory around that, and before that we discussed route tables, right? So where we created a software router and then configured routes, whereas your network traffic will go through a specific device in a subnet, right? So that's what we had seen in our earlier classes and in our earlier class. And then on top of that, as an extension of that, we discussed little bit theory on the load balancer, right? So Azure load balancer. So we'll go and continue with that load balancer itself today as well and see how do we configure the load balancer and what are the different settings that which are available and what are the different solutions you have within the load balancer itself. Right. So that's what the agenda for today. And if time permits, we'll go ahead and discuss a little bit about Azure gateways, right? Azure VPN gateways or virtual network gateways, that's what we call it as, right? So that's what the agenda for today. Okay. So as we discussed in our earlier class, let me take this load balancer, right? So what is a load balancer? A load balancer is a device that which will help you to load balance the or balance the load of certain components, right? So let us take an example like you have a web servers, multiple web servers, And these web servers, if let us say that if there is no load balancer kind of stuff, what will happen is if once one device is down, or the traffic might still go to that, right? So or the traffic might not be segregated across different virtual machines equally. That means that one of your web server might be overloaded, one of the web server might not be utilized appropriately, right? Now these are certain problems that which we have. That's where your load balancer will come into picture, right? So what load balancer does is it basically binds all your virtual machines as something called as backend pool, which we discussed, right? So as a part of backend pool, you have a pool of virtual machines, right? Now this pool of virtual machines will be tagged to your load balancer, right? So if this is your load balancer, all your virtual machines will be tagged to your load balancer, right? This will be tagged to your load balancer. And because your load balancer is having a pool of resources, and it will redirect the traffic to one of the resources which are part of this particular backend pool, right? We'll see how does that happen and other stuff. Coming back to the backend pool itself, right? So we are saying that a pool of resources. So does that mean that I have to add individual virtual machines to the backend pool? Or do I need to use any existing solution within the Azure where you have a bunch of virtual machines, right? Now, the solution is both ways, right? So you can add individual virtual machines in a backend pool. Individual VMs can be added. And you can also add our availability sets.
Vijay, backend pool is nothing but the cluster, right? You're putting in the cluster.
I will talk on that. We'll talk. Let us complete these 3 points, then you will understand how exactly it is. Okay. So we'll understand these 3 points. What are those 3 things that which can be part of, or which can be included as a part of backend pool? Then you'll easily understand. Just
Okay.
wait for 2 minutes. Okay.
Okay.
Yeah. Then we have something called as virtual machine scale sets. Now we didn't discuss the third one. The first one is anyway self-explanatory. You can add individual machines. Second one we discussed, right? Availability sets. What is an availability set? Availability set is nothing but you have a group of virtual machines which will be part of your update domain or fault domain. What it means that you are adding a group of machines which again have some backend high availability solution in place, right? Let us say that you have an availability set which is already having 4 or 5 machines. That means that if you add your availability set to the backend pool, then you will have all those machines part of your availability pool itself, which means your load balancer will redirect its traffic to the machines which are part of the availability sets, right? And again, because why availability sets, you definitely want to have again a high availability at your virtual machines level itself, right? So that's the reason you want that level of high availability, and you want to avoid hardware failures or update unavailability of services during Microsoft updates and so on. Then you go and put your virtual machines in an availability set, right? In our case, web servers. Now I can go and straight away add availability set to the backend pool. That is the second option. So first option is you manually select individual virtual machines and add it to them. And second option is you go and add an existing availability set where you are getting a high availability because you have fault domain and update domains, and you are avoiding the physical hardware failures and update unavailability of services during the updates, right? So those type of situations you can go and use your availability sets. And the third option that what you have here is virtual machine scale sets. This we didn't discuss. So let us quickly look into that. Anyway, we'll be discussing in detail in our future classes. But what is this virtual machine scale set? We call it as VMSS, virtual machine scale set. Virtual machine scale set is a solution where you can increase the number of virtual machines in a pool based on certain conditions, right? Let us say that I created a virtual machine scale set. I will call it as VMSS1. And it will ask you to select the base image to create the virtual machines, which means that you need a base image for the creation of this. Now using this base image, you specify create, okay, 5 virtual machines. Okay, which means that now this virtual machine scale set has got 5 virtual machines. Now you write a condition here saying that if CPU utilization of these machines is greater than 90%, go and increase 2 machines. Which means based on certain conditions, you are increasing or decreasing the number of VMs or instances in your pool. Not necessarily with the CPU, but it can also be any parameter for that matter. You can also schedule it. Let us say every weekend your utilization of web servers is very high. What you can go is you can go and schedule every weekend from Friday night to Sunday morning, increase the virtual machine count to 3, which means that it will add additional 3 machines to the existing pool. And again after Sunday morning, it will revert it back to -3, right? Now virtual machine scale set is a solution that which will help to auto increase your virtual machines within a virtual machine pool, right? That is called as virtual machine scale set. Now this is again a very good solution to integrate with your load balancer, isn't it? So your load balancer is a front end and your back end web servers, and you want to have a virtual machine scale set which automatically takes certain decisions based on the load. Let us say that you as a company are into a sale, right? Thanksgiving Day sale or whatever, right? Or a Diwali sale, and you don't know what will be the traffic, and you cannot even guess sometime, right? Now these type of solutions, the virtual machine scale set solution is definitely a best thing to use around those type of situations, right? You go and specify the conditions and they scale, what do you call it, as scale out to the extent whatever is needed, right? So you not only can specify how many how many machines it can increase, but also you specify what is the wait time between 2 thresholds, right? What is the wait time between? Now you increased 2 machines. How much time it has to wait to go and take that call again, right? That's what you go and specify in the wait time, right? So these are certain things that which you get as a part of virtual machine scale set, right? So here you have 3 options where I can go and use within the backend pool. One is add individual virtual machines, add availability sets, add virtual machine scales, right? Now if you go back to your question, this gives you an answer that yes, that is a pool of machines which are a web servers pool or whatever, an application pool or whatever, which you can go and add to the backend pool which you create when you create a load balancer. Hope that answers your question. If not, you can ask if that doesn't.
Yeah, yes. Actually, when it is a pool of things, that itself is a cluster, right? So that's how
Exactly.
you can add it.
Yeah.
Yeah, got it.
Yeah. Now you have a front-end load balancer. You have a back-end pool. Now how does users access this? They need something called as an IP address, right? Now this load balancer can be an internal load balancer or an external load balancer. If it is an external load balancer, your IP will be public. right? If it is internal, it is private IP address, right? Right? Now, up to here, everything is fine. Let us say that one of the VM is kind of misbehaving and the web service itself is down on this particular machine. Now, if your load balancer doesn't have a method or mechanism to identify the health of the machines in the backend pool, your users may still be routed to a machine which is down, or the service which is down, and so on, right? So that's where they'll provide us something called as health probe. Health probe. Now in health probe, you go and write certain conditions to your load balancer. Okay, so if it is web server, you tell to your load balancer, boss, go and check the state of the web services, every 5 minutes, 2 minutes, or 1 minute, or 50 seconds, or whatever. Now, if the web service is down, then your load balancer will not send traffic to that particular virtual machine, right? That is the use of the health probe. And it takes that call of unhealthy call of a VM being unhealthy or service being unhealthy after 2 or 3 attempts. That what you define. How many attempts you want your load balancer to, how many times it has to attempt to take a call that your what do you call it as service is down, right? So that is what a health probe is, right? Now you have a load balancer front end, health probe, back end pools, right? And there's something called as load balancer rules. Load balancer rules that we will be seeing. What are those? But your load balancer rules will have a health probe tagged. Okay, it will also have a back end pool tagged. So all these things are combined together in a health probe rules. And the last one, you have something called as natting. Natting also is another solution which you have within the load balancer, right? Now, what is natting? Network address translation, right? So you can use a public IP address to translate it. If you don't want to directly expose your servers to the internet, you can use a solution called as natting. And within natting also there are different solutions, right? One-and-one natting, which means that one IP address to one IP address, or you can use multiple ports to one IP address to connect to multiple backend servers, which means that if I have 3 virtual machines here, right? So if your public IP address is XXXX, and you can translate that to connect to one of these virtual machines, which we are going to see in some time. Okay. Yeah, somebody.
What is the full form you said? Natting?
Network address translation.
Network address translation.
Yeah.
Gotcha.
Right. So as the name itself says, you are translating one of the IP address to something else in the backend, right? So you are basically shielding your backend environment because of some reasons you don't want to expose whatever. So that time you can go and do something called as network address translation. That is called as NAT. Okay. Now let us quickly jump into our practical listing and see how do we actually configure this. Okay, before I go there, another important thing. Load balancers you get in 2 forms. One is basic, second one is standard. Okay. So of course the standard one is they will charge, which means that cost. This is free. So Microsoft recommends to use standard because of various reasons. There are advantages that which you get when you go with standard on top of basic, like number of instances that what you can go and create within the standard is more when compared to the basic. And within basic, you don't get the HTTPS traffic load balancing, which means that you cannot use more. See, if you are an organization and want a secure communication, that too over internet, why do you go with basic, right? So you definitely want to go with HTTPS, right? So there are certain advantages that which you get when you go with a standard. including the SLA as well, right? However, the cost of the standard is more when compared to the, cost for standard is like it is not free. That's what we can say. Whereas standard is, whereas basic is free. Okay. So these are the two types of load balancer you get. One is standard and basic, which you have to go and select when we go and provision. So this we call it as SKUs, right? SKUs, right? Stock keeping units, which is nothing but the cost perspective, right? So let us go to our web portal, Azure portal, and see how do we create a load balancer, right? So balancers within the Azure portal. Okay, so here you have an option called add, right? So let us click on add. Okay. So resource group, I already created a resource group that which we will be using, right? Demo LB, and the name of the load balancer, right? I'll call it as demo load balancer, and region where you want to put this one. I'll put this in Central India. Right? I'll put this in Central. Now here you see two types of load balancer. As I said, private and then public, right? Which is internal. The other one is external. Now if I go with public, then I have to create a public IP address because my users will be accessing from outside. If I go with internal, I don't need a public IP address, but what I need is it picks an IP address from the virtual network. That's what you go and select here, right? So if you want to go with an internal load balancer only for intranet kind of stuff, then you can go with internal. If you want to go this with a public IP address, then go with public IP address where you need to create a public IP, right? So that is public or external. Now, as I said, there are two types of load balancers, standards and basic. For this lab, we'll go with basic. And then the IP address that which is needed. I don't have an IP address, existing IP address. I'll go and create a new IP address, which I call it as demo public IP, right? And you want that to be static or dynamic. I want that to be static because it's good to have a load balancer with a static IP address rather a dynamic which changes whenever you reboot or refresh your load balancer, right? So let us go ahead and create it. So you just created a load balancer, okay? So we haven't configured the load balancer. So the next step what we'll do is we'll go and configure the load. So to configure the load balancer, there are multiple things, right? One is the front end IP address. Second one is back end pool, right? These are certain things that which are needed. Let this get created. Right, so this is the configuration of your load balancer. And you see, let that overview pop up. You see a public IP address is assigned to this particular load balancer, right? and that is nothing but your front-end IP address. Our front-end configuration is nothing but an IP address assignment to your load balancer, right? That could be a private or a public. Now here you have something called as backend pool. In the backend pool, as I said, you need to create a backend pool. For that, you need to just go and click on add and select what is that you want in the backend pool. So what are the options you have? You have an individual virtual machine, or you can go and add virtual machine scale set, or you can add an availability set. That's what you see here. Now your backend pool, let us name it as backend pool. Now go and select what is that you want. Now if you want to add individual machines, go and select individual virtual machine and you can add it, right? Single virtual machine, right? So it will load the list of virtual machines you have, then you go and manually select which virtual machine you want to add. But in our case, we have created an availability set which we will be using, right? I have already created the availability set. I just did it before the lab because we had already covered the availability set. How do we create and what is that another stuff in our earlier classes. So to save the time, so I had created that before the lab itself, right? Now I have an availability set. Now I need to go and select the availability set here, right? So I select the availability set, then it will give me the list of availability sets in this particular region, right? So I have two virtual machines as a part of this availability set, right? So it will give me an option to add network configuration or network IP of those virtual machines, right? So what did you do? You went ahead and selected availability set. When you select the availability set, it will give you the list of availability sets that which you already created. Then you go and select the availability set that which you want to add to this backend pool. You selected the virtual machines, but you did not add them. To add them, you have to click on add a target network IP configuration. Then it will give me the list of machines part of this particular availability set. Now, how many machines I have? I have two machines, right? I should be able to see both the machines here, right? I can see them. Go and select VM2, which is the first VM that which I want to add, and network configuration of that particular machine, which is nothing but your private IP address, right? Which is 10.0.0.5. Okay. Now you added first virtual machine. I also want to add second machine, which is part of the availability set. Click on add target again. Add target network IP again. Then go and select the first one. And then add the network interface card or IP configuration, which is 0.0.4. Right? 0.0.4. Now you added for the virtual machines to the backend pool, which are part of your availability. Say it as. Now once it is updated, what you can see here is the list of virtual machines which are part of your backend pool. Right? I'm waiting for that to complete. Just shows only one virtual machine. Let us wait for that to update. So likewise, we can add a virtual machine scale set also. Okay, so we'll see that virtual machine scale set when we come to the topic, because okay, you can see two virtual machines part of this backend pool, right, and with their private IP addresses and network interface cards, right. So that's how you can add a backend pool. Now you have a front end IP address which is assigned, right. You have a availability set which is backend pool. Now what is left is you have to go and put a health probe in place so that your load balancer understands what is that condition it has to check, or what is that service it has to check to make sure that your backend pool of VMs are healthy. If they are not healthy, it will drop what you call it as traffic to those VMs. For that, you have here something called as health, right? You have something called as health. You can go and add a health probe here. You can add a health probe here, right? Let us say that demo health probe. And this health probe, you can go and select the protocol, right? You have multiple protocols here, right? HTTP and TCP. If you go with what you call it as standard, you will get more here, right? You will also get HTTPS and other stuff, because we are going with basic. That's the reason we're getting only two, right? You can go with, let us say that it's a HTTP traffic. Then you will go and add HTTP, right? It will go and check / is the default web page path, and you can see that, right? So every 5 seconds it will go and check the health of the port, that what you defined here, port or protocol, using the port and protocol, the service it will go and check every 5 seconds. Now after two consecutive failures, default is 2, after two consecutive failures it will take a call that okay, this service is unhealthy and let me drop traffic to this. And anyway, it will go on checking that every 5 seconds until it feels that things are fine, right? So that's how you can go and create a health probe, right? You can go and create a health probe based on your requirement, right? This is health probe. Now you created a backend pool, you created a health probe, you have a front end IP address, right? Now you have something called as load balancing rules. Now here in this load balancing rules, what you do is you go and use the health probe, backend pool and front end IP addresses to bind them together. That's what your load balancing will do, right? Right? LB rule. Right? So this LB rule will define what is the front end. So you are binding all of them. That's what you can think of, right? Now what is a port through which the communication should happen on the front end? So which is 80, which let us say that because it's a web server, I am selecting it as port 80, right? Need another space. Okay. Right? So you also see a backend pool. If you have multiple backend pools, you can go and select from here which one you want to put into this, and you have a health probe. Right? If you have multiple health probes, you go and select from the drop down box. And apart from this, you have something called as session persistence. Now within the session persistence, you have three options rather, right? Now a session persistence will tell if a traffic is coming from the same IP address, client IP address again and again. Do you want the traffic to be routed, or do you want that session to be routed to the same web server in the backend, or you want to route it to a different one? So you are basically defining, if it is same client IP address, you may want to send the traffic or send the web page, whatever activity you are doing, to the same backend server in the pool, right? So that is what a session persistence is. So here you have three options, whether you want to consider only IP address or IP address and port number, or you don't want anything, right? So these are the three options, right? So I'll leave that as none, and then I'll go and create a, what do you call it, as load balancer rule, right? This is load balancer, right? Now you have your web services load balancer ready to go ahead and use it. Now what users can do is users can go ahead and use this front-end IP address to access the web services which are sitting in the backend, right? So you need to make sure that you have IIS installed if it's a web service, or any application for that matter if it is any other application that which you are going to load balance, right? So that's how you can go and configure a load balancer within the Azure, right? Now there is another important concept here which is called as NATing, right? Network address translation, right? Let us quickly look into it, what it is. Now this load balancer, what we had seen, has a front-end IP address, right? It's got a front-end IP address. And using this front-end IP address, that whatever I have, I want to connect to these machines. Let us say that these machines doesn't have a public IP address. Let us think so. These machines are internal and they don't have public IP address. They have only 10.x series IP address, which means that you will not be able to access them over the internet. Now, what is the solution you have to access? You put one more machine here facing the internet, connect to this, and use this as a gem box, which is again having two IP addresses, right? One is the public IP address, one is 10.x IP address. Because this is configured with 10.x IP address, you can connect to them by using this gem box, right? That's how generally in most of the organizations they will access outside, from outside or the internet to the internal environment. You will have one gem box and access, right? That is one way. The other way, what you can do is you can use this IP address, public IP address, whatever you have, and using some port you can connect to this particular machines, right? Let us say that if it is 5000, port for 5000, connect to VM1. It is 5001, connect to VM2, and 5003, 5002, connect to VM3. So what do? You go and put MSDSC and then put your public IP address and then colon 5000. So what this will do is, your load balancer is intelligent enough. Any traffic which is coming on the public IP address with 5000, it knows that there is a NATing rule defined, and it goes and checks, okay, if the traffic is coming on port 5000, what do I need to do? Now here in the load balancer rule, you go and specify if something is coming on port 5000, route it to VM1. That's all, right? So this goes and routes the traffic to the VM1. And if you are putting here instead of 5000, 5001, then it routes the traffic to second VM, and so on. So you are basically attaining a network address translation using the public IP address which you already have, by just putting a port number to individual virtual machine, right? Let us see how do we configure it, right? Click on add within the NAT rules. Right. So here you go and say that rule 1. What is the rule 1? Okay, front-end IP address is the same one. Now what is the service you want? I want to use RDP service because I want to do an MSDSC, right? I want to do a RDP service. Click on service. You can see multiple services here, right? I want to go and select RDP. and which selects the port 3389. That is the source port, right? If this source port has to be associated to what? Associated to some virtual machine within the, what do you call it as, availability set, right? Let us go back. So this is availability set where we have come. Let us go back. Let us associate it to some virtual machine. Click on availability set virtual machines. Let us select VM2, right? Then you will get the network interface card. Select the network interface card of VM2. And then what is that you want to map this port to? I'll select custom, right? So now what you are saying is, from source, if it is 3389, go to 3389. But from source, I want to put this as 5000. Okay. Now somebody is hitting this particular front end IP address, which is 52.172.141.133 on port 5000. Where it should go? It should go to the destination, which is your VM2. And to which port it has to map? It has to map to your RDP port. So if I use public IP address colon 5000, it is getting mapped to your VM on 3389, which means that it is allowing you to take RDP session, right? Let me go and create this NAT rule. Likewise, you can create multiple NATing rules if you want. Again, this is basically based on your requirement. You can go and do it, right? So let me create only one. We'll try to see if we can access that particular virtual machine using the rule, NATing rule, that what we created just, right? So what did you do? You specified here, okay, 52.72.172.52.172.141.133 on 5000. And where it should land here on 3389, right? On 33, that's what you specified, right? That's what you specified. Let us go and see if that is created, right? This rule is created. Now if I go and access this particular virtual machine on that port, then it should be able to allow you to RDP to that particular machine VM2, right? Let me go and put 52.172.141.133 and put 5000, right? So it is prompting you to take RDP of that machine, right? Now I can go and create one more rule for the second virtual machine on 5000 or 5001, right? Likewise, you can create multiple rules for each machine which is part of this particular load balancer, right? That's how you can also do NATing. So what did we see? We had seen how do we configure the front end, how do we configure backend pools, how do we configure health probes, how do we bind all of them using load balancer rules, and how do we create a inbound NATing rules for your backend pool of machines, which are nothing but machines which are part of backend pools, right? So this is what we have for load balancing. So one thing that what you can do when you are doing a lab, you can put IIS on these machines, and then you can also customize the web page and try to access it. That will give you more accessibility or better demonstration, right? So for this lab, what we had done is we had used availability set with a normal VMs. I don't have IIS installed, so I couldn't able to show that. But this is how you will be able to configure front end, back end, health probes, and then load balancing rules. Okay. So I'll pause here. If you have any questions, we can take.
So basically, the public IP, the load balancer, wherever we are specifying, it's nothing. It shouldn't be in the same region. It can be in any region, right?
No, it has to be in the same region where your availability set is. When you create a load balancer, it will ask you the region as well, right? So it has to be
Uh-huh.
in the same region where your availability set or virtual machine scale sets or the individual machines reside,
Oh, it should be in the same region.
right? Right.
Okay.
Otherwise, you will not be able to see them when you try to add them. If it is in a different region,
Exactly.
you will not be able to
Yeah.
see them, right? Any other questions, guys? Okay, so if no questions, we have another 15 minutes. So what we'll do is we'll quickly go and look at another important and interesting topic, which is Azure VPN gateways. Okay, Azure VPN. Okay, so what is a gateway? We all know, right? A general terminology in the infrastructure world, a gateway is nothing but a router. Right? We call a router as a gateway, which allows traffic to move between different regions or between two routers or between two what do you call it as buildings or whatever, right? Uh, so you use router to connect to geographical locations or to buildings or to data centers or whatever. Right? So over the internet, if you want traffic to be sent, you will sending it through a gateway and again through a firewall and so on, right? So similarly, like how you have a gateways in routers for your physical infrastructure, Azure has also got something called as Azure VPN gateway, right? Now, what is this Azure VPN gateway, and what is the advantage of using Azure VPN gateway? Now, let us take a situation or scenario. Uh, you have uh, you have on-prem environment and you have some workload on Azure as well. Now, you want to integrate your on-prem environment to Azure, right? That is one situation where you have all your Azure workload should go through communication of or traffic of your Azure workload should go through a gateway, and that gateway in turn should get connected to your on-prem and vice versa, right? Or let us say that you have few workloads in Azure and you have few workloads in other cloud. Let it be GCP or AWS or whatever. And how do you connect? You use some gateway. You can use Azure Gateway to connect, right? Or let us say that you have two VNets, virtual networks, in two different regions, right? So if it is in the same region, you can go and do a VNet peering, which we had seen, right? Virtual network, where you go and create a connectivity between two VNets, and then they communicate with each other. Now, if they are in two different geographical locations, you will not be able to do a peering, right? Peering is only for those VNets which are in the same region, right? In those situations, you still need something called as a gateway, right? Now, these are the basic uses or requirements where you go with a gateway or Azure VPN gateway. One is VNet communication, connectivity. Second is site to site, we call it as, right? That includes your site to site includes a terminology that includes your connectivity from different site to Azure or cloud to Azure also. That can be the configuration is same. There's one more thing called as point to site. Point to site. Now, point to site is something where you have an application hosted on cloud. Let us think so. And your user who is sitting on internet will have to access the application that which is hosted on the cloud. Then you go with some solution, VPN solution, which is called as point to site, right? So these are few things which we should be discussing, and there's something called as express, right? Now for today's class, what do? We go and look at the site to site configuration. How do we do it? And then we'll look at VNet to VNet and point to site and other things also. Okay. Now let me go back to the site to site one. Right. Let me remove this and put some diagram here so that we can understand. Now let us say that this is your on-prem. This is your cloud infrastructure. Now your requirement is to enable communication between these two. So you will have a router here with some x.x.x.x public IP address, and you will also have a gateway here, right? You will also have a gateway here with some y.y.y.y IP address, right? Something like that. Now, if you have multiple virtual machines which are part of this, which are again part of a VNet, right? All your virtual machines will be part of a VNet, and this VNet will be binded to your router here, whatever it is, which is nothing but a gateway, which is nothing but your gateway. So what it means that any traffic which is flowing out of that virtual network will go through that gateway, and that gateway will have a configuration which defines or which tells what is the router of the on-prem, what is the route to which the traffic should flow, right? That's what we are going to see. Now for that, we have multiple things that which we need to understand, right? So first thing first is your VNet, which we had already seen. VNet, which is nothing but a network boundary. Each VNet will have what? Multiple subnets, right? Subnets. Multiple subnets. So you have an option within the VNet to go and what do you call it as? Create multiple subnets. And there is something called as gateway subnet. Gateway subnet. Let us quickly go and see. I'm not sure whether you observed that when we created a virtual network. Let's quickly go and see what is a gateway subnet. Right. This is the VNet which we already have. Let us go and look at the configuration of this. We go to subnets. Right. Click on subnets. Within the subnet, you see an option to create a subnet, right? And you also have an option here which is called as gateway subnet. Now, what is the difference between a gateway subnet and subnet? Though the name sounds same, but there's a difference. A gateway subnet is, well, you can create, there will be only one gateway subnet per VNet. You will not have multiple gateway subnets. You will have only one gateway subnet. Now, why this is used and what is the purpose of this? The gateway subnet is used by your routing configuration, right? So all this routing configuration that whatever you go and put in place will be part of your gateway subnet. And this gateway subnet will also have an address prefix. This will also have an address prefix. And the IP address range, whatever is specified in the address prefix, will be used by your routing to create one or two virtual machines which are used for routing table purpose. Okay, that's what the use of the subnet. But we'll not be able to see those machines and other stuff. That is basically used at the back end by your routing configuration to store the routing tables and configuration information about your route. Okay, so when you create a site-to-site configuration, you definitely need something called as gateway subnet that basically will have some routing configuration, right? Now, if I click on add subnet or add gateway subnet, what I see here is it picks the name automatically and it selects an IP address range. Selects the IP address range, right? You can go and click OK to create the gateway subnet. Of course, you can change it if you want. Yeah. So let us say that I didn't see what is the IP address range, but 10.0.1.0/20, right? I think it is not in the range. You would have seen that VNet range, but anyway, we'll try to see if this answers. Let me go and look at the range of that VNet so that we'll give right address space there. Now it is 10. Overview. Okay. So it is using 10.0.0/24. What did I use here? So we basically used everything in that VNet. So that's the reason it might not be allowing us. But when we create a VNet tomorrow, we'll see. But what you have option here is you have something called as gateway subnet, which you can go and assign a range of IP addresses for the gateway subnet. As I said, gateway subnet is used to basically put some virtual machines. Those machines, whatever is configured or which will be there on part of this gateway subnet, are used to store the configuration of your routing. Okay, so you need something here which is more in specific called as gateway subnet, right? Apart from the subnet. So you need a virtual network, you need a subnets to put your virtual machines or traffic to which it should go, and you also need something called as gateway subnet. Three things, right? So here, what we need VNet, we need subnet gateway or gateway subnet. You also need something called as subnets, which anyway will be there, right? So when you create a router, it definitely asks you, okay, boss, tell me what are those VNets through which I have to take the traffic, right? So when you create a gateway, it will ask you those details, right? VNets details. You can tag multiple VNets also to one router, right? So when you tag a VNet, it will ask you, it will automatically pick the gateway subnet also, because there will be only one gateway subnet, and it adds all the subnets which are part of the VNet, right? So on Azure, when you create a router, which is nothing but your gateway, you will need all this information, right? That is one. On the on-prem, so you have to integrate this to here, right? Now there is something called as local gateway. Local, something called as local. Apart from Azure gateway, there is something called as local gateway. Now, what is this local gateway? Local gateway is a configuration. Local gateway is a configuration on a gateway which will hold IP configuration of on-prem. IP configuration of on-prem. So this local gateway will hold an IP address of x.x.x.x. And this local gateway, because it knows the IP address of on-prem, what you do is just go and tag this local gateway also to your Azure. Then it will have all the information, right? So what information now your gateway got? Your gateway got the backend information to which it has to communicate on the Azure itself, which means that what are the VNets to which it has to communicate, and what is the gateway subnet of individual VNet. That information it will have for the Azure part, but it has to communicate to your on-prem. So for that, we will be tagging something called as local gateway. Now what is this local gateway? Local gateway will have a configuration information of your on-prem router, right? So there is no option where within the gateway configuration itself I can go and enter the on-prem details. What I have to do, I have to create a local gateway. I have to tag this local gateway to my virtual network gateway on the Azure. Then your Azure virtual network gateway knows what is that IP address to which it has to communicate when it's trying to route the traffic to the on-prem, right? So this is at the Azure part. Similarly, here on the local part also, on-prem router also, you will be configuring the details of your gateway, right? You will be configuring the details of your gateway. Now here for our lab, what we will be doing is we are going to use Windows 2016 routing and remote access. Routing and remote access. Right? We are going to use Windows 2016 routing and remote access, which will act as a router. And on this router, we'll go and configure our Azure gateway. Right? Now this IP address range is 10.10.0, and let us say that this is 192.168.0.0. The internal IP addresses. The moment you establish a routing between these two, you should be able to access the resources which are on-prem on the Azure and vice versa. So if you have a web server here on one of the VM, you should be able to access that web server in one of the machine in our lab, right? So what we will be doing is we have one lab that what we will be using. Let me show you that. This is our machine with a public IP address of 103.69.28.117. And what we will be doing is we'll be configuring this machine as a router. Okay, so this machine is having 103.69.28 and 117, and it also has an internal IP address of 192 series, right? This 192 series IP address, 192. So after I configure this routing and remote access, I should be able to access all the resources here on my Azure without any issue. I should be able to RDP using 10.0.0 IP address, and these people, whoever are sitting on Azure, should be able to communicate with 192.168.0.0 directly without using any public IP addresses, right? So that's what we are going to see tomorrow, right? Now this machine gem box that what we have here will act as a router, and using this router, we'll be communicating with the resources which will sit on our Azure environment. So tomorrow it may be an hour or a little bit more than that. So just you need to give some additional 10-15 minutes for me to complete the entire session, because I'll try to reduce that by having a gateway created, but I still have to explain how do we, because gateway creation itself will take 1.5 hours for the configuration and other stuff. Though you initiate it, it will take 1.5 hours or 1 hour to complete that configuration. So what I will do is I will have one gateway which is readily created. And we'll also create another gateway, which anyway will be kind of taking 1.5 hours. And we'll see the configuration part of gateway creation. After that, we'll go and switch back to the gateway which I already created, right? So that's how we'll be able to manage the time better, right? Otherwise, we have to split this into two classes, and again, it is a kind of break in between the concepts, so which I don't want to do it. So tomorrow when we start, we'll be discussing once again these concepts at a high level, and then we'll go with the site-to-site configuration, where we will be integrating our environment, which is uh, in our lab, right, to the on-prem, right? So that's what we are going to do tomorrow, right? So if you have any questions, you can ask. I think otherwise we are done for today. But tomorrow's class is important. Just don't try to miss it. Actually, you mm, don't get people won't show you this in other institutes, where this configuration and other stuff which we are going to see tomorrow. Okay, so don't try to miss that. Okay, so, yeah, so we will not be using the physical router. That what we generally it will be. We are replacing that physical router with software router, because we don't have physical router. So that's the only difference, right? So you may have to skip the Windows routing remote access configuration and other stuff, but what you need to understand is the routing configuration part, right? So to configure the router, I am using Windows 2016 with routing and remote access role installed, as we have seen in other classes as well, right? So for route tables also we use the same thing. So likewise we'll be using this. So we'll see. Yeah. Any questions? Then we'll take. Otherwise, I think we are done for today. Okay, so no questions. Then we are done for today. We'll catch up tomorrow in the morning at the same time, guys. Thank you. Right, bye.